Good morning to everyone and lecturer. Today in this video I would like to briefly introduce our project. Based on the project we have doing the image classification regarding the historical building. First, now I am showing the flowchart. So we have created a total 19 images with 10 images for each of the 3 buildings at a different time period. Next, we need to perform the data pre-processing, manually grouping. Based on the feature extraction, we have to use LDA to do it. On the train model, we have used SVM and KNN to test the model, which can get the high accuracy that the algorithm will be chosen from us to create the system. Lastly, based on the result, we have to display about the report and the confusion metric. Furthermore, at the pre-processing, the more important part is need to create a label for each list of files. After that, also need to resize the image. Here I am showing about the label for each image, and after the label has been created, we also need to set as the .h5 file. Continue here have showing more detail about the code of feature extraction. Besides, we have used LDA to do it. Before that, we have also split the dataset into a 70% training set and a 30% for testing set. In this case, n component equal to means that the LDA algorithm will project the original feature space onto a 2-dimensional space. By reducing the dimensionality to 2, it becomes easy to visualize and interpret the data. Here I have shown the shape of test and training after we use the LDA. Based on this project, we have tested the KNN and SVM. We get the SVM performance is more better. So based on this project, we have using the SVM algorithm to be our prediction method. So based on the SVC kernel, we have set the linear is because the linear kernel define a decision boundary as a hyperplane in the original feature space. It is suitable for the linearly separated data when the class can be separated by the straight line or plane. The linear kernel is computationally efficient and can work well in many cases, especially when it's a linear relationship between the feature and the target variable. So after that, here I am showing the result confusion metric, classification report, and the accuracy based on the algorithm of SVM. At the end of this video, I will show the demo. Based on the system, I have used the Gradio to be our interface. After that, I use the class mapping to set the label for each historical building. Then set a function to pass the input user into an algorithm to predict the label of the user input. Now, let's try. Here I have an interface, and now we need to input the image. Let's wait for a while. Okay, this is the result, and this the image label is 0, so it will display about the A Formosa. No, that's all for me. Thank you.